So dear students, again welcome for the 7th session of this solution chapter. In the last 6 different sessions, I think we have discussed the 2 different types of liquid solutions. One is gas liquid solutions, and then the second one is liquid solutions. Means the homogeneous mixture of a gaseous solute in a liquid solvent is called as gas liquid solution, whereas the homogeneous mixture of a liquid solute in a liquid solvent refers to which one? The liquid solution. So the main concept relative to the gas liquid solution is based on its absorption coefficient, and that has been clearly stated in the form of Henry's law. Whereas the concept of liquid solution is explained according to the concept of Rolle's law of liquid mixtures, or it is also called as Rolle's law of binary liquid solutions. So then that binary liquid solutions, we can have the 2 different types called as an ideal and then the non-ideal solutions. And then again, as if there is no exact behavior with respect to an ideal, because the solution is going to be ideal if and only if the solution is going to be very dilute. Means we can have the real existence with respect to only the non-ideal solutions, but those non-ideal solutions can be of 2 types, that is called. The first one is a non-ideal solution showing a positive deviation, and the second one is a non-ideal solution showing a what deviation? Negative deviation. Okay. So there we have discussed the graphs for that, and then what are the various differences between those 2, ideal and non-ideal, and then non-ideal showing a positive deviation and non-ideal solution showing a negative deviation. Okay. So this is all what we have discussed in the first 6 different sections for the concept of gas liquid solutions and then the liquid solutions. Now we will have the concept of which one? SL solution. There itself it is having a meaning at the definition. So what is that? Homogeneous mixture of solid solute in a liquid solvent is called as which one? The solid liquid solution. Means here, when solid gets in contact with the liquid, what happens? It undergo a process called as usual I mentioned, dissolution taking place. Means the solute particles have the interaction with respect to the which one? The liquid solvent molecules to have a dissolution. And the reverse can also is considered to be it is called as crystallization also. What's that? Crystallization. Means some solute particles gets collided with themselves to form a solid crystals. That is why the process is considered to be the what? Crystallization. But during the dissolution of a solid in the liquid, these 2 can happen in opposite rates. That is, the rate of dissolution of a solid in the liquid is equal to the rate of crystallization of that particular liquid particles into the solid. There one equilibrium is reached, and that is called as the solubility. Okay. So for ionic substances, what that? Ionic substances, the dissolution of the dissolving capacity is based upon its hydration energy. If the hydration energy is found to be greater than that of its lattice energy, then the salt or the electrolyte start to get dissolved. Suppose if the hydration enthalpy is found to be less than the lattice enthalpy, we have mentioned that the dissolution doesn't take place. Indirectly we will discuss that in the form of the solubility and then the solubility product and then the ionic product, that actually we have discussed in the equilibrium chapter for the class 11th. That is the solubility product and then the ionic product. Okay. So right now, this particular solid liquid solution is explained on the basis of a new type of physical property called as colligative properties. Here it is derived from letter co means together and ligare means to bind. Means they will start to bind out here. Which will start to bind out here? The solute or the solid solute particles will bind or gets together, bind with the which one? The liquid solvent molecules. So that is the property related to that one is considered to be in the form of which one? The colligative properties. But this colligative property is not applicable for all the type of solid liquid solution. It is strictly for the dilute solution. So then how to define this particular colligative properties? Okay. These are the physical properties of strictly the which solution? Dilute solution. These are strictly the physical properties with respect to the which one? Dilute solution, which depends on the number of moles, or indirectly we can mention this also, amount of solute particles, but not on its nature, chemical nature, or it may be the size. So this is the definition related to the which property? Colligative property. They are strictly the physical properties with respect to the which one? The dilute solution, in which depends on which one? Those colligative properties or the physical properties depends upon only the number of moles. What is the number of moles? Indirectly called as amount. Amount of which one? The solute particles, but not on the chemical, depends upon the number of or the amount of solute particles, but not on its chemical nature, or it may be the size. And also it is mentioned that these properties are not dependent upon the amount of the solvent, but it depends only upon the amount of the which particles? Solute particles, but not upon its either the chemical nature, or it may be the which one? Size. Okay. So here these colligative properties with respect to dilute solutions are of totally 4 types. These colligative properties can be of 4 types. What is that? The first one is lowering of vapor pressure. Lowering of which one? Vapor pressure. This having a symbol of delta P we are calling. Then elevation of boiling point or in boiling point. It is having a symbol of delta TB, I think. Then we are having the depression in or depression of freezing point having a symbol of delta TF, and finally we will have the osmotic pressure, that is having a symbol of which one? Pi. What is that? They are the special properties with respect to, or the special physical properties with respect to what solution only? The dilute solution, where it depends upon, means those physical properties depends upon the which one? Number of moles, or indirectly it is called as amount of the which particles? Solute particles, but not upon its either the what nature? Chemical nature, or it may be the size. So here these colligative property with respect to that particular solution can be of 4 types. That is called as lowering of vapor pressure, elevation in boiling point, depression in freezing point, and finally the osmotic pressure. Okay. So then we have to discuss individually, means we have to discuss each of these are proved to be what properties? The colligative properties. Okay. So let us have one by one. First, the first colligative property that we are choosing is lowering of vapor pressure. Lowering of which one? Vapor pressure. The first ever colligative property. Because if we know the vapor pressure concept, means I can easily define what is the elevation in boiling point and then the depression in freezing point. But the osmotic pressure is totally a different concept compared to that of these 3 colligative properties called delta P, delta TB, and then delta TF. Okay. Let's have the first discussion. Lowering of vapor pressure. This is having a symbol of delta P. Delta P means lowering of vapor pressure. So first, what is pressure as usual? Pressure means it is the force acting per unit area. Force acting per unit length is actually called as surface tension, whereas the force acting per unit area refers to the which one? The pressure. Okay. So that is the definition of a pressure here. First, what is vapor pressure? First, what is pressure? It's the force per unit area refers to which one? The pressure. What is Vp? What is Vp here? Vapor pressure, that I already discussed when we are discussing the concept called as the Raoult's law of liquid mixtures. Means during the formation of a liquid with respect to the liquid solution, that is liquid solution. What is the vapor pressure here? It is an equilibrium pressure exerted by the vapors of liquid in contact with its own, in contact with its own liquid. It is what pressure? An equilibrium pressure exerted by the vapors of that liquid in contact with its own liquid at an interface. Indirectly it is called as the surface of a liquid actually. Means we know that any liquid on its surface has a respective vapors. How that vaporization takes place? By the absorption of heat from the surroundings. As the vapors of the liquid gets moved out means they also start to get condensed if the system is found to be closed. The reverse of that one is called as condensation. Means from the forward process we are expecting the vaporization of the liquid, and in the another stages, that is at the junction, we are expecting the condensation of its vapors. As these two processes are occurring simultaneously, at the interface called as a separating phase, or it is also called as a boundary or the surface of the liquid, what happens? The rate of vaporization of the liquid is exactly equal to rate of condensation of the vapors of that liquid. So there we are expecting one equilibrium pressure, and that equilibrium pressure is called as what? Vapor pressure. Okay. So that is, we have already mentioned that in the form of also the equilibrium pressure exerted by the vapors in contact with its own liquid at its what phase? Interphase. So now we know that increase in temperature increases the Vp of the liquid. Usually increase in temperature increases the vapor pressure of the liquid. Okay, means decrease in temperature decrease the vapor pressure of the liquid. Okay. Now what is that lowering of vapor pressure? So I think first it is we have to be very familiar with what? These two pressures. What is that? What is vapor pressure? Sorry, what is pressure and what is vapor pressure? What is the pressure first? It's a force acting on a system per unit area. Okay, what is the vapor pressure? An equilibrium pressure exerted by the vapors in contact with its own liquid at the junction, or it is also called as interface, where the rate of vaporization of the liquid is exactly equal to rate of condensation of its own vapors. Okay. Now what is lowering of vapor pressure? Let us have an illustration with respect to this. This is now the liquid which is now acting as a what? Solvent, which is having a solvent. And we know that these are the vapors of the which one? Liquid. What these are? The vapors of that particular liquid under consideration at constant temperature. Here the temperature is found to be kept constant. Okay. Because at constant temperature the vapor pressure of the liquid is found to be the constant. How the vapors exerted here? It is due to the absorption of heat from the surroundings. At the junction what happens? There occurs one equilibrium pressure, and that pressure is called as P naught. What is P naught here? It is the P naught is the vapor pressure of this particular liquid in the form of solvent. Because now we have to add the solute, that is why you are not using the word as liquid, but I am using the word as which one? Solvent. What is P naught here? It is the vapor pressure of the pure liquid in the form of which one? Solvent. Okay. Now it is at a constant temperature. Now, if I add a small amount of a non-volatile solute, if I am adding the what? Small amount of a non-volatile solute. Why would you add the small amount of a solute? Means because we have to prove that it's a colligative property. As it is a colligative property means the solution must be very, very dilute. How we can make the dilute solution here? Means we have to put the small amount of which one? Solute with the large excess of the given solvent. That is why we have to add a small amount of which one? Non-volatile solute also. Means that solute doesn't start to get vaporized even when it is exposed to air. That type of solutes are called as what? Non-volatile solutes. For example, sugar in water, glucose in water, sodium chloride in water, aluminum sulfate in water. What these are? These solutes are non-volatile. For example, alcohol in water. Alcohol is also vaporizing, water is also vaporizing. Therefore, alcohol is not an example for a non-volatile solute, it is a volatile solute. Means strictly with respect to the lowering of vapor pressure, what do you have to take? A non-volatile solute. That to be the what amount? Small amount. Means what happens when a small amount of a non-volatile solute is added to the given solvent? So first the thing is, this becomes liquid solvent now becomes with solution, dilute solution. What solution here? Dilute solution. So here, this is the representation with respect to the solute I am mentioning. Why I am adding the smaller, why we are having a very small particles of solute? Because it is a dilute solution. What those dotted lines represents here, it is the solute particles. We are adding the small amount. What happens when a non-volatile solute of small amount is added to the which one? Pure solvent. First it forms a what? Dilute solution. Okay, next. What about the vapor pressure of that particular liquid? Because the solute that we have added is not vaporizing. Only the liquid solvent that we have added is found to be the vaporizing. Then what about the vapor pressure of that? So here, as if we know that it is an open system, this solute particle is moving first. This solvent molecule is moving like this. It blocks that. Means one vapor gets less. Why? By absorbing the heat from the surroundings, what happens? The surface molecules, what it will do? It will start to get vaporized. But what that solute particles will do? It blocks the movement of the which molecules? One solvent molecule, such that its vapor gets decreased. Let us take another solvent molecule is moving. Again there is another which one? Solute particles. Therefore another vapor has been left. Similarly this is also moving. This blocks the surface. Therefore this is moving. This also blocks. This also blocks. Means what the solute will do here? It blocks the movement of some of the solvent molecules which are moving or escaping in the form of respective vapors. Therefore, the net resultant is the number of vapors of the pure solvent gets decreased. Means it is not the vapor pressure of the liquid here, again it is the vapors of the which one? Solvent. Means what is the vapor pressure is now? Whether it gets increased or decreased. As if the number of vapors of the liquid solvent gets less means what about the pressure here? The collision is also less. As the collision is also less means what we can decide? The vapor pressure is also less. But what is that vapor pressure here? It is called as P. That P is called as vapor pressure of which one? Solution. It is not the vapor pressure of the solvent because we are having the solute with the solvent. But before adding the non-volatile solute, it is only the pure solvent. Therefore, the vapor pressure of the pure solvent is higher as compared to that of the vapor pressure of the given solution. Okay. So here at the junction, we are expecting one vapor pressure, and that vapor pressure is called as P, and that P is called as what? Vapor pressure of the solution. Vapor pressure of the solution. Means, what about the vapor pressure here? It gets decreased. That is why the word is found to be the what? Lowering of vapor pressure. Therefore, how to define this one? It is the decrease in the vapor pressure of the solution. Decrease in the what? Vapor pressure of the solution due to the addition of a non-volatile solute to a pure solvent. Means if what is added to what here? If a small amount of a non-volatile solute is added to the pure solvent, what happens? The vapor pressure of the solution goes on decreasing. That decrease in the vapor pressure of the solution due to the addition of a what solute? Non-volatile solute to the pure solvent is called as what solution? Lowering of vapor pressure. Lowering of vapor pressure. Or we can define that in another mathematical form as it is the difference in the vapor pressure of the pure solvent and the vapor pressure of the given solution. Means which is more here, which is less here? The vapor pressure of the pure solvent is more. Why? Because there are more number of vapors that has been emerging from the surface of the liquid. Why? Because there is no entrance of the which particles? Solute particles. As if we have added a non-volatile solute, means what those solute particles do here? They will block the movement of the which one? The vaporization of the some of the liquid molecules, such that the vapor pressure of that particular solution goes on decreasing. That is why vapor pressure of the pure solvent is more and then the vapor pressure of the solution is going to be less. Therefore, the difference of those two is called as what pressure? Lowering of vapor pressure. Means it is the difference in the vapor pressure of the pure solvent and then the vapor pressure of the which one? Solution. Okay. So mathematically, what is that? Mathematically, LVP is given by delta P. What is LVP? Lowering of what pressure? Vapor pressure is equal to delta P and that is equal to P naught minus P. P naught minus P. What is P naught here? Vapor pressure of the pure solvent. V naught is what? Vapor pressure of the pure solvent. What is P? Vapor pressure of only the solution. Means the difference of those two is called as what? The lowering of what pressure? Vapor pressure. Means we can define that in the two different forms. What is the first one? One is, if what is added to the what? If a small amount of a non-volatile solute is added to the what solvent? Pure solvent, then what happens? The vapor pressure of the original solution or the dilute solution gets a decrease and that particular decrease is called as what pressure? Lowering of vapor pressure. Or with respect to the mathematical concept, it is defined as lowering of vapor pressure is just the difference in the what? The vapor pressure of the pure solvent and then the vapor pressure of the solution. So here what is that? Here P naught is Vp of pure solvent. Vp of pure solvent. Whereas P is Vp of only the solution. Therefore the difference of which and which? The vapor pressure of the pure solvent and then the vapor pressure of the solution is called as lowering of what pressure? Vapor pressure. So inside of that we are having another one. Relative lowering of vapor pressure. After knowing the concept of lowering of vapor pressure, we are having another one that is called as relative. Relative means it is called as ratio. What is that? It is the ratio of LVP. What is LVP? Lowering of vapor pressure to the vapor pressure of the pure. Which one? So it's just the ratio. Ratio of which by which? Lowering of vapor pressure to the vapor pressure of the pure solvent is referring to relative lowering of vapor pressure, which is named as RLVP. Mathematically, RLVP is equal to P naught minus P divided by P naught, which can also be equal to delta P by P naught. So this is called as what? RLVP. What is P naught minus P? It is called lowering of vapor pressure. P naught minus P is also called as a delta P. Delta P divided by P naught. What is P naught? The vapor pressure of the pure solvent. Therefore, how to define the Relative lowering of vapor pressure, it is the vapor ratio of what? Lowering of vapor pressure to the vapor pressure of the pure solvent. So I think you have very perfect with respect to the lowering of vapor pressure. First, when what is added to the what here first? When a small amount of a non-volatile solute is added to the what solvent? The pure solvent. The vapor pressure of the solution goes on decreasing. So therefore that decrease in the vapor pressure of the solution due to the what? Addition of a non-volatile solute to the pure solvent is called as what pressure first? Lowering of vapor pressure. Or with respect to the mathematical concept, it can be defined as, it is the difference in the vapor pressure of which and which? The vapor pressure of the pure solvent and then the vapor pressure of the solution. Because usually the vapor pressure of the solvent is found to be very higher compared to that of the vapor pressure of the solution. Why? Because there is no hindrance for the evaporation of the liquid in the form of its respective vapors if it is a pure solvent. But if a non-volatile solute is added to the pure solvent, what happens? Those solute particles, what it will do? They block some of the vapors of the liquid that has been emerging or moving from the surface of that particular liquid. That makes the vapor pressure of the solution found to be less, and that is called as the lowering of which pressure? Vapor pressure. If I take the ratio of which by which, lowering of vapor pressure to the vapor pressure, the pure solvent, means that ratio is called as a relative lowering of what pressure? Lowering vapor, relative lowering of what pressure? Vapor pressure. Okay. Next, we will have one law related to this. So next we will move on to the law related to this. Rolle's law of RLVP. Rolle's law of what? RLVP. We have discussed another same Rolle's law with respect to the liquid mixtures. Liquid mixtures. What is that statement here in case of a liquid and a liquid solution? The partial vapor pressure of the liquid in the liquid mixture is equal to the product of vapor pressure of that liquid in its pure state into its respective what fraction? Mole fraction. That is called as the Rolle's law of liquid mixtures. But now we are having another one that is called as Rolle's law of relative lowering of vapor pressure, which is applicable for a solid liquid solution. That Rolle's law is applicable for a liquid solution, but RLVP refers to the which solution? Solid liquid solution. So what is the statement here? Statement. At same, what's that? Constant temperature. At what temperature? Constant temperature. The RLVP. What is RLVP? Relative lowering of what pressure? Vapor pressure. Is equal to the mole fraction of solution. This is a statement. What is that? At what temperature? Constant temperature, the relative lowering of vapor pressure is equal to the what fraction? Mole fraction of that particular solute. Okay. So mathematically, P naught minus P divided by P naught. What is P naught minus P divided by P naught? It is called RLVP, relative lowering of what pressure? Vapor pressure, is equal to X2. This X2 is also given by N2 divided by N1 plus N2. What is this? Here as usual, what is P naught? VP of solvent, pure solvent. Okay, what is P? VP of the respective solution. X2 is called as the mole fraction of solute. N1 is number of moles of solute. solvent 1, whereas N2 is the number of moles of solute. Okay, so this is the mathematical statement with respect to which one? The Rolle's law of RLVP. What is the statement here? At what temperature again? Constant temperature. The relative lowering of vapor pressure, P naught minus P divided by P naught is called as what pressure? Relative lowering of vapor pressure is equal to X2. What is X2 here? It is called mole fraction of the solute. How to calculate mole fraction of a solute? It is the number of moles of the solute divided by total number of moles in the solution. That is N1 plus N2. That is N2 divided by N1 plus N2. Okay? To prove LVP is a which property? Colligative property. What do you have to prove now? Lowering of vapor pressure is an example for a what property? Colligative property. How to get the colligative property with respect to the lowering of vapor pressure? By RL of RLVP. RL of RLVP. We know that P naught minus P divided by P naught is equal to N2 divided by N1 plus N2. What's that? It is the statement related to not the statement, it is the mathematical relationship with respect to the Rolle's law of what? Relative lowering of what pressure? Vapor pressure. Or for which solution? Dilute solution. Which solution? Dilute solution. For dilute solution, can I say that N1 plus N2 is nearly equal to N1? Why? Means we have neglected N2 compared to N1. Why? Because as if it is a what solution? Dilute solution means amount or number of moles of a solute is going to be very, very less as compared to that of the more amount of the solvent. Therefore, N1 plus N2 is nearly equal to N1 with respect to what solution? Dilute solution. Therefore, P naught minus P divided by P naught is equal to just only N2 divided by N1, or P naught minus P is equal to P naught divided by N1 into N2. P naught minus P is equal to what? P naught divided by N1 into N2. But for a given solution, at constant temperature, at what temperature? Constant temperature, P naught is constant. What is P naught? Vapor pressure of the pure solvent or vapor pressure of the liquid at what temperature? Constant temperature is always constant. Then N1 is also constant because the solution concentration varies with the amount of the solute particles but not upon the which one? Solvent. Means with respect to the given solution at constant temperature, P naught is found to be the constant and N1 is also found to be the constant. Therefore, P naught minus P is equal to constant into N2. Constant into what? N2. Because P naught is constant, N1 is constant, means what is P naught by N1 is, that is also a constant. Therefore, P naught minus P proportional to N2. Delta P is proportional to N2. What's the meaning of that? What is delta P? Lowering of vapor pressure. Lowering of vapor pressure. Lowering of vapor pressure varies directly to N2 means what is N2? Number of moles of the what particles? Solute particles. With respect to what solution? This is obtained only with respect to the what solution? Dilute solution. Therefore, we can decide it is an example for a what property? Colligative property. Because what colligative properties are? They are the physical properties of restricted for the what solution only? Dilute solution, which depends upon only the number of moles of solute particles but not upon its what nature? Chemical nature. Therefore, as P naught minus P called as a lowering of vapor pressure is directly proportional to the number of moles of the which particles? Solute particles for the dilute solution only. Hence, LVP called as a lowering of vapor pressure is an example for a what property? Colligative property. Okay. So, that is the concept of or the application of which law? Rolle's law to prove that it is an example for which one? The colligative property. Okay. Next, how to get the expression for molecular mass of a solute using the help of LVP or RLVP. Next is expression for molecular mass of a solute using a colligative property called as LVP. What is LVP? Lowering of which pressure? The pressure. Means the molecular mass of the solute can be obtained if we know the value of which one? LVP. What is LVP? Lowering of what pressure? By RL of RLVP. What's that? By the Raoult's law of relative lowering of what pressure? Vapor pressure. By Raoult's law of which one? The relative lowering of which pressure? Vapor pressure. We know that P naught minus P divided by P naught is equal to N2 divided by N1 plus which one? N2. N2 divided by N1 plus N2. Let us call that equation as 1. But for dilute solution, which solution we are considering? Dilute solution. Can I mention N1 plus N2 is nearly equal to N1? Why? Because as we are taking that as a dilute solution, means amount of a solute is going to be very, very less as compared to that of a very large excess of which one? The solvent. Therefore, I am neglecting the value of N2 as compared to that of N1 plus N2. Therefore, instead of N1 plus N2, I will mention that in the form of only the N1. Therefore, P naught minus P divided by P naught is equal to just only N2 divided by N1. N2 divided by N1, which is equal to W2 divided by M2 divided by W1 divided by M1. Why? Because number of moles is given by W by M. How do you get number of moles? W by M. What is W? Mass. Mass divided by which mass? Molecular or molar mass. Therefore, N can be written as W by M. Therefore, what is N2 can be written as? W2 divided by M2 and N1 can be written as W1 divided by which one? R. P naught minus P divided by P naught is equal to, if I simplify that, W2 M1 divided by W1 into M2. W2 into M1 divided by W1 into M2 R. I need the molecular mass of solute. What is the symbol for that? M2 is equal to, what is M2? Molecular mass of 2 means it is a solute. M2 is equal to what? P naught divided by P naught minus P into W2 M1 divided by W1. So this is called as the expression for which one? Molecular mass of a solute using the help of which one? LVP. What is LVP here? Lowering of what pressure? Vapor pressure. So here M2 is what? Molecular mass of or molar mass of which one? Solute. Okay. What is M1? Molecular mass of a pure solvent. What is P naught? Vapor pressure of the pure solvent. What is P here? Vapor pressure of the given solution. What is P naught minus P, or indirectly it is called LVP. What is LVP? Lowering of what pressure? Vapor pressure. Then what is W1? W1 is what? Mass of solvent. Mass of which one? Solvent. What is W2? Mass of which one? Solute. So just by knowing the value of LVP, what is LVP here? The lowering of vapor pressure, which is an example for a what property? Colligative property. We can find out the what mass? Molecular mass of the given solute. Okay. So this is about the first colligative property, that is called as what? lowering of vapor pressure. So to get the lowering of vapor pressure, first what is vapor pressure? Then we are having what is pressure. The force acting per unit area is considered to be the what? Pressure. What is vapor pressure? It is the equilibrium pressure exerted by the vapors of the liquid in contact with its own liquid at the interface, or it is also called as a boundary, or it is also called as a surface of the liquid. Or it is an equilibrium pressure exerted where the rate of vaporization of the liquid is exactly equal to rate of condensation of the vapors of that liquid. Usually increase in temperature always increase the vapor pressure of the liquid. Then what is lowering of vapor pressure? It is the what is added to what here? When small amount of a non-volatile solute is added to the what? The pure solvent. Those solute molecules will block the movement of the vaporization of some of the liquid solvent molecules such that the vapor pressure gets decreased, and that is called as what pressure? Lowering of vapor pressure. Means it is the lowering of vapor pressure is what? It is the decrease in the vapor pressure of the solution or the liquid due to the addition of a what? Non-volatile solute to the what solvent? Pure solvent. In case of mathematical concept, it is mentioned as, or it is defined as, it is just the difference in the vapor pressure of the pure solvent and then the vapor pressure of the solution. Means the difference of P naught minus P will use the what? Lowering of vapor pressure, which is mentioned as delta P. After that, next we will have the RLVP. What is RLVP? Relative lowering of vapor pressure. Just it is a ratio. What is that ratio here? Relative lowering of vapor pressure is the ratio of what? Vapor pressure of that particular liquid divided, it is the ratio of what? Lowering of vapor pressure to the vapor pressure of the pure solvent. That is P naught minus P divided by P naught is called as a lowering of vapor pressure. By knowing the concept of relative lowering of vapor pressure, next we will move on to the law called as what law here? Rolle's law. What is that Rolle's law here? At what temperature? The constant temperature. The RLVP, what is RLVP? Relative lowering of vapor pressure is always equal to which fraction? Mole fraction of the solute. Mole fraction of the solute. Mathematically, P naught minus P divided by P naught is equal to N2 divided by N1 plus N2, where N2 is the number of moles of a solute divided by N1 plus N2 is the total number of moles of both the solute and then the solvent. Okay. So that will decide, or the Rolle's law of RLVP decides what? It is an example for a what property? Colligative property, if and only if the solution is restricted in the form of what solution? Dilute solution. And again, the same lowering of vapor pressure helps to calculate the what mass? Molecular mass. What is the direct formula there? M2 is equal to P naught minus P naught divided by P naught minus P into W2 M1 divided by W1, where P naught is the vapor pressure of the pure solvent and P is the vapor pressure of the solution, and P naught minus P is called as a lowering of what pressure? Vapor pressure. W1 is called as a mass of a solvent and W2 is the mass of the solute, whereas M2 is now considered to be the molecular mass of the solute. Okay. So in the next session, we will move on to the second colligative property, that is called as elevation of boiling point. Elevation of boiling point, which is also called as ebullioscopy, having a symbol of delta TB. Ebullioscopy, or it is also called as which one? The elevation of which point? Boiling point. Okay. So that we will discuss in the next session of this particular chapter, that is called as solutions. Okay. So thank you.